Hello everyone, welcome to my third channel. This is my math and science channel. And for the first video, I will explain what is idoneal numbers. I think it's how we say it. Because when because I don't think there's any idoneal numbers videos on YouTube. So let's start. So definition. A number is an idoneal number if that number is part of a monomorph. What is a monomorph? A monomorph is an integer that can only be expressed in the form of x squared plus or minus dy squared, or x squared and dy squared have a greatest greatest common divisor of 1. And also, by the way, d is an ideal number. Okay, so let's get to it. Okay. Oh, continue. And yeah, where x and y are distinct numbers, and like I said, we finished. A number is an ideal number if the result of its monomorph x squared plus or minus dy squared, where x squared and dy squared have a great common. And the result of this, if you put like a number which is an ideal number, will be prime power, or twice a prime power. And also there's a simplified way. The ideal numbers cannot be written as AB plus BC plus AC, where the numbers are integers and zero is less than A and and B is A is less than B and B is less than C. Example, all numbers from 1 to 10. And here is an example. 1 squared plus or minus 5 times 3 times 3 squared equals 2 plus. So plus or minus 5 times 9, which equals to 2 plus or minus 45, which equals to 47 or minus 43. We'll just keep in mind of the positive result, and 47 is a prime, so 5 is an ideal number. Here's a counterexample with a simplified definition. 11, because it could be written as 1 times 2 plus 2 times 3 plus 1 times 3. Okay, so let's continue. Also, a person who discovered are the people who discovered it are Gauss and Euler. And also they made a conjecture on ideal numbers. Ideal numbers. There are only 65 of them. Here are all of them. There's also in 40, well, 1848 is the biggest ideal number. Next one is the possibility of more ideal numbers. The first person that made a theory was Peter James Webinger, but the second one who made like a paper at Ernst Canny, which which I'll which is, he made a very big research paper on iodian numbers. But I'll if you want to read all of them, go in the description because it explains 10 times better than me. And and go and then I only add theorem 22. It says there's at most one fundamental discriminant. But what is a fundamental discriminant? A fundamental discriminant is an integer that isn't equal to 1, not divisible by any square of any prime, and when modulated to 416, gives d remainder 1 in mod 4, or d remainder 18 or 12 in mod 16. Okay, let's continue. And at the theorem 22, he says that is the most one fundamental discriminant, and he uses the delta symbol, which means congruence conditions modulo, which is less than minus 400 5416, which as you see is part of the group, with C delta. This means the class number of the congruence condition modulo will equal to 1. And also the second thing is If the generalized Riemann hypothesis is proven, the class number of the congruous condition model is less than one. If the congruous condition model is a fundamental discriminant with the CCM less than 5,460. Okay, let's continue. This is if you want to read the whole proof, here it is. I'll give you 5 seconds. Okay, let's continue. Next one is corollary 23. He says that there's almost one square free ideal number that is greater than the current highest number. But what is a square free number? Square free number is a natural number not divisible by any perfect square, like a 1, 4, 9, 60, 25, etc. And there's three possibilities. One, 180, 848 is the biggest ideal number. This is not proven. It's still a conjecture that that this number is the biggest ideal number. Two, there's at most one idoneal number bigger than it, and it must and also must satisfy that the number must be remainder one in modulo 4. And the third possibility is that there's two ideal numbers bigger than 1,848. Also, the small one must have a remainder 2 in mod 4, and the bigger one of the two is must be 4 times bigger than the smaller one. Okay, so let's continue. So right now there's 65 ideal numbers. This is still a conjecture because it's not proven if there's more of them or there's only 65 of them. But there's a possibility of one or two more. So and thanks for watching, guys. And here are the sources that I use. It will be in the link description if you want to see more information. The this one by Ernst Canny is the most has a lot of information. I covered like 1% of all of the things. So hey guys, if comment below what should I do on this channel. Okay, goodbye.